camera tripods really slow down recording my videos, so I wanted to make a better version, or at least try. Because annoyingly, I find myself either tripping on them at the worst times, getting pinched by them, or just wasting my life away for 30 seconds at a time, adjusting for shots, when in reality I could spend a fraction of that time. Using a camera dolly and yes, a cast iron pan, we'll start with marrying these two together. I designed some brackets and printed them on my new Bamboo Labs printer, which I just bought. I've owned quite a few printers over the years, and finally printers are getting to the point where they are just plug and play, which is awesome for entry-level people. These brackets will mount to the cast iron pan with an adjustment knob, so I can easily remove the base when needed. All I have to do is measure out the spacing from the center and make them equidistant from each other. Shown here are the adjustment knobs I got on Amazon, and they should work perfectly to secure the base down. I then mark out the upright bracket and size up the holes for drilling. My reason for the cast iron is it's cheap and heavy, and it was really easy to purchase on Amazon. Eventually I got fed up with the drill and did some hand drilling, but later switched back because I realized that sharp bits are very important. That being said, my drill press is very weak and it is lacking for sure. I'm also drilling out this washer to add strength to the 3D printed bracket to clamp everything together. Here is the fender washer that really solidifies the connection. As you might be able to see, the inside diameter hole has some grooves cut in there so that when they go on the camera dolly, they position correctly, and when I undo the base, it won't flip around and it'll stay neatly in place. Next, I pop on the cast iron pan and secure it down. And as we move upwards, I have some parts in, made from my first sponsor, which is JLC PCB. They were kind enough to supply me with not only printed circuit boards, but CNC machine parts as well. My parts came quickly and were packaged really well. They not only offer bare PCBs for you to assemble, which is what I'm doing, but they also do full service PCB assembly. The machine parts also look incredible with threaded holes and a perfect surface finish. And on top of that, they have hardware and mechatronic parts as well. Ordering was easy, just upload a file and make your way down the list, adding quantity, PCB thickness, and color, among other things. Upon checking out, they provide you with a cost breakdown and options for speed up, building, and shipping times. I'd highly recommend them for your next project. So yeah, these aluminum parts are pretty chunky, and I did that for two reasons. Really, it doesn't increase the cost very much, and it adds mass, which I really want lower on the camera rig. I grabbed these large steel gussets and secured them with M12 screws to the cast iron pan. So that pretty much sums up the base. Now let's focus on the electronics of the project. When it comes to electronics, I'd say I'm pretty okay. Mostly comfortable working with pre-assembled modules like USB power delivery units, motor controllers, and ESP boards. They make it so much easier to assemble on a bare circuit board and get your project off the ground, like this one. After everything is assembled, I just adjust some settings and look at voltages real quick just for a sanity check. I just quickly code something up with the help of ChatGPT and do some testing. I'm powering the unit with a standard NP battery and moving the gantry up and down using a stepper motor with GT2 timing belts. The motion is controlled by some capacitive touch modules and LEDs I had left over from a past project. The unit operates with a double tap to toggle the motor, middle buttons for up and down movement, adjustable speed settings, and limit switches to prevent gantry crashes. Next, we'll work on the vertical column for the gantry movement, making and drilling the mounting holes and locations as well. By the way, I just launched a Patreon. Joining will get you extra and early content as well as access to a Discord server where you can preview projects and see how they're made and even share your input. Check it out if you'd like to support the channel. And a quick question, do you prefer mechanically focused videos like this, cool design projects like the chessboard you are seeing, or easy DIY builds like the Zen garden shown that anyone can do with little tools and supplies? Let me know. And finally, here's a look at the refrigerator portion of my next big project, an over-engineered coffee table packed with more surprises. Now back to the build. After I finish drilling the holes for the vertical column, I need to countersink the holes to make the screws sit flush so that the vertical gantry can move up and down without binding on the screw heads. And here are the remaining aluminum brackets that will be secured as we move up the column. Here I'm cutting the vertical column, and then you can see the up and down movement right here. Followed by the horizontal bracket for the horizontal gantry. Sorry for all the nomenclature, I'm even more confused than you. I'm a little worried about the tolerance on the T-track and the rubbing against the aluminum. So I got this PTFE tape that I'm going to be putting on the sliding surfaces. So again, this portion shown is how the horizontal arm where the camera is will slide freely. And then most of these parts will need to be tapped and then countersunked accordingly. Another interesting part aside from the cast iron pan is a 10-pound weight that will serve as the counterbalance for the camera so that it slides up and down relatively easy. I then drill and tap holes for both the weight and securing the counterweight assembly to the vertical column. It'll all make sense once it comes together. Okay, so drilling the holes in this thick cast iron plate was surprisingly and oddly satisfying. It felt like drilling into a hard block of cheese. Anyway, once that was done, I had to cut down some screws because I ordered the wrong ones, and then clean them up and give them a cool down. And then on to the final assembly. I'm just painting the gussets, and then I will create the housing for all the electronics to sit on the actual camera jig. Ignore the blurry scene here. I just cut myself and it was a pretty bad one. So the main electronic stack will sit inside the vertical column just below the stepper motor, with the controls easily accessible. The nice thing about this NP battery mount is that it has a power delivery output, so I can request 12 volts from a standard USB and then use that to power the stepper motor driver, and also step down the 12 volts to 5 volts to power the other stuff. Finally, here is everything coming together. This is the counterweight assembly that I'm working on right now. After everything is good and tightened down, then we add the cast iron counterweight. And then here sped up is the actual camera side, so the opposite of the counterweight, which will balance each other out. Now putting everything back together, and then I just kind of do a sanity check to see if everything's level, and then start my way up again. Now comes the fun part of the actual the mechanism to make the camera move up and down. I have the stepper motor and a little bracket to go along with it. I have the pulley and then 2 idler wheels that will kind of guide the G2T belt down into the slot. And this is what I meant by feeding it into the slot. It goes just right down there. Next, I feed the belt through a pre-drilled hole done off camera and secured it outside with a gripper aluminum kind of piece for a snug hold. All right, now I can mount the camera gantry, I guess I would call it, to a arc Swiss plate. I didn't have the correct bolt size, so I again had to grind that off and then secure it with a lock nut. Electronics are going in. I'll then feed the stepper motor wires as well as the limit switches through this little hole. Again, off camera, I made a mount for the limit switches that fit real nicely on either side for the up and down movements. Now it's a matter of plugging everything in and giving it a quick check. I have yet to add a decal for the buttons, but that will come later. And for now, that's it. So yeah, that's the camera slider. I'll now show you the functionality. So it has adjustable feet, an easily swappable battery, an extendable counterweight and camera arm, a touchscreen for motor controls, and a variable speed function for different shots that I want. So this design could be more rigid for sure. There's still some play in the T-tracks and there's occasional binding. The PTFE film helped, but adding more brackets for better gantry alignment should fix it. Overall, a solid first attempt at a vertical camera rig and should make filming much easier. Again, thank you so much for watching. Consider liking and subscribing or joining my Patreon. Have a great day.